Hello everyone, my name is Han and today I'm going to show you how to differentiate a function by using chain rule. So first off, I'm gonna put this tablet down and then you probably see the ceiling up here, but just want to let you guys know that I'm still here. So I'm going to do that and I'm going to pick a color pen, and then the title for this is going to be chain rule. So chain rule, it's really helpful when you take the derivative of the composite function. So let's take a look at what is a composite function. So chain rule says if you have a function in terms of h of x equal to f of g of x, which means a function within a function, then h prime of x it's going to be f prime of g of x multiplied by g prime of x. So that means in able to take the derivative of h of x, you're going to take the derivative of the whole thing right here and multiply by the derivative of inside the parenthesis. So let's take a look at one of the example. So example number 1. Whoops. Okay. Let's say I have a function f of x equal to x plus 3 squared. So how do I differentiate this? The derivative of this is going to be f prime of x equal to, you treat this function like a power rule, so you bring down the 2. So it's going to be 2 times the parentheses stay the same. Let me rewrite that. Plus 3. And then the power, obviously you subtract 1, so it's going to be 1 multiplied by what the derivative of inside of the parenthesis, which is 1. So your final answer is going to be 2x plus 3 or 2x plus 6. Alright, this is just a really simple example. Let's look at the more complicated one. So example number 2. What if your function is f of x equal to, let's say, 4 times x squared plus 2 to the 4th power. You can use the power rule for this, but it's gonna take so much time to expand this function, this part right here, and you don't want to do that. This is why chain rule is coming to handy. So let me make a note. Chain rule is helpful when you have a function with a high power. So the power in this case 4, and then that is really time consuming and complicated to solve it by hand, so that's why we're going to use chain rule. So what chain rule say, f prime of x, the derivative of this function is going to be you use the power rule first, so apply the power rule, bring down the 4, so 4 times 4, whatever inside the parentheses stay the same, x squared plus 2, and then the power is going to decrease by 1, so 3 multiplied by the derivative of inside the parenthesis. This part right here, it's going to be 2x. And your final answer is going to be 16 times x squared plus 2 cubed times 2x. And then you can simplify it further. 32x times x squared plus 2 to the cube. And this is your final answer. Let's take a look at one more example involving trig function. So, let me zoom in here. Example 3. So what if your function f of x equal to secant squared of x? So the derivative of this f prime of x, you can apply the power rule first. So f of x equal to secant squared, this is the same thing saying that it's equal to secant of x, the quantity squared. So you apply the power rule first, bring down the 2. So it's going to be 2 inside the parentheses, stay the same, secant of x. And then the power decreased by 1, which is 1, multiplied by the derivative of inside the parentheses. So the derivative of secant, it's secant, let me rewrite that. It's secant of x times tangent of x. So your final answer is going to be f prime of x equal to 2 secant squared of x times tangent of x. Okay, and here I'm back, and this is like some basic example for using chain rule, and thank you guys so much for watching.